The Enterprise Insight Analysis solution accelerates the data-to-decision process by empowering organizations to turn massive data sets into actionable intelligence and insights. I'm playing the role of a Tier 2 SOC analyst working at a financial institution. Upon beginning my graveyard shift on October 19, 2013, I accessed my organization's workflow management system to start processing escalation tickets. My first ticket involves analyzing a QRadar offense indicating possible proxy beaconing to known botnet C2 nodes and connections to known malware sites. I start by searching for the QRadar offense in question using the quick search bar within our intelligence portal. This simulates a data on an access on demand connector to our QRadar instantiation. I see the QRadar offense in question providing me quick context. I add the results to the chart for further analysis. I perform an expand search against the QRadar instantiation to bring in related entities of interest within 1 degree of separation, such as the internal host who's communicating with possible C2 nodes. I apply organizational layout to reorient my results. Here's a digital asset which appears to be a DHCP server with an IP of 10.0.100.190 and another related QRadar alert. I perform another expand search on the QRadar alert to see what else is related. I see both QRadar offense and alert involves the same host. Since the offense and alert categories involve possible proxy beaconing, I want to analyze this host's net flow around the date of notification. Traditionally, this would require me as an analyst to take significant time to learn and write complex scripting queries against QRadar, where I would have to perform manual correlation on the results to stitch information of interest to me. Visual Query provides a powerful searching capability, allowing analysts to think and draw their queries against big data sets without having to write long, complex SQL statements. Results are returned in seconds, not hours. For the ease of time, I execute a saved visual query searching for net flow analysis. This includes the digital asset in questioning, communicating with another digital asset on the date of question, which is October 18, 2013. I add the results to the chart for further analysis. Results are an enormous clutter. I quickly search for the host in question and apply a circular layout to help facilitate analysis. I use the list most connected analytic to help me gain quick context on the amount of net flow traffic between digital assets. List most connected analytic allows me to list highly connected entities and the links between them against several different analytics. Using the most links, I am able to list entities based on the number of connected links. I see our host in question has 424 net flow communications. I also notice communications are single direction and low in amount of connections, which starts to concern me as this might be an indication of proxy beaconing activity. Typically, human-led browsing patterns often have more communications. I also notice how the communication is outgoing for my internal host, which likely indicates call home. With bar charts and histograms, I have the ability to slice and dice the data based on categories and ranges. I am able to analyze the net flow data temporally by event timestamps to see if I can identify any unique patterns, which is often an indication of proxy beaconing, as it requires specific and controlled machine-to-machine communications to provide instructions. I see that the first set of communications occur at around 11:15 p.m. on October 18, 2013. I notice that there is also other sets of communications that occur slowly around 11:30 and 11:33. I drill down into this group of communication patterns in question. By analyzing the data with the heat matrix by seconds, I see a unique pattern exists where communications shift by every second. This unique pattern further confirms that there is in fact proxy beaconing activity occurring on my network. By modifying the previous visual query for net flow analysis, I am able to enrich my information with threat intelligence data available within my data holdings. I want to see if any digital assets communicating with my host in question have any threat intelligence indicators. I also want to understand if there are any known associated campaigns with said indicators. I add my results to the chart and see how in fact there are connections within my original alert NetFlow data with known indicators. I add the information to a new chart to simplify visual analysis. By applying an organizational layout, I see an internal host had 3 NetFlow connections with outside IPs who are listed on IP address watch list as indicated by my threat intelligence data. All indicators are connected with the Dridex botnet. By opening the Dridex botnet entity, I'm able to read a description of the campaign provided by US CERT. In this case, the primary goal of Dridex is to infect computers, steal credentials, and obtain money from victims' bank accounts. I fear there are more Dridex botnet IOCs matching my communications with my internal network. With ease, I am able to simply draw out this question and search against my data using visual query, starting with a campaign entity, which would be restricted to the Dridex campaign, connected to any known indicators, paired up with digital assets who are communicating to internal network hosts. My fear is substantiated with the results. I add them to a new clean chart to facilitate analysis. By applying an organizational layout, the network picture becomes clearer. Leveraging bar charts and histograms, I see how I have 76 indicators and 156 digital assets. In addition, I can see one of the hosts is the DHCP server in question with IP 10.0.100.190. And I have 79 workstations communicating with outside IPs matching known Dridex IOCs. Very quickly, we have been able to evaluate whether proxy beaconing activity occurred as indicated by our SIEM alerts. The activity observed matched IOCs attributed to the Dridex botnet. The extent of internal workstations at this point in my analysis, I have packaged up my findings and communicate with my network teams to deploy mitigation strategies to combat Dridex.